From childhood wonder to cutting-edge physics, rainbows hold secrets deeper than their colorful display suggests. As quantum mechanics reveals nature's hidden rules, these beautiful arcs might be showing us glimpses of parallel universes and fundamental cosmic mysteries. Let's explore the amazing science that creates these sky-high light shows. When sunlight hits a raindrop, something magical happens, but it's all thanks to physics. The light doesn't just bounce off the drop, it bends as it enters, reflects off the back, and bends again as it exits. This process, called refraction, splits white light into different colors because each color travels at slightly different speeds through water. Think of it like running on different surfaces. You move faster on pavement than in sand. Red light travels faster through water than violet, so they bend at different angles. That's why rainbows always show the same color pattern. Red on top, then orange, yellow, green, blue, and violet on the bottom. But here's something cool. Every person sees their own unique rainbow because it depends exactly on where you're standing relative to the sun and rain. Now let's dive into one of the strangest parts of rainbow physics: quantum superposition. When light travels through a raindrop, it doesn't just take one path. According to quantum mechanics, it actually takes all possible paths at the same time. This isn't just some wild theory. Scientists have proven it through experiments. Think of it like this. Instead of a light beam choosing a single route through the raindrop, it explores every possible path simultaneously, like a crowd of people all taking different routes to the same destination. When these paths meet up again, they create patterns that give us the rainbow's perfect arc shape. The light waves either work together to make bright colors or cancel each other out to create dark spaces. This quantum behavior explains why rainbows appear exactly where they do and why their colors are so pure and bright. Let's connect rainbows to one of the most famous experiments in physics, the double-slit experiment. When scientists shine light through two tiny slits, something amazing happens. Instead of seeing just two bright lines on the screen behind, they see many stripes, an interference pattern. This looks a lot like what happens in rainbows. In both cases, light waves overlap and create patterns. When light travels through raindrops, it's actually doing something similar to the double-slit experiment, taking multiple paths and interfering with itself. This shows us that light isn't just a simple beam, but behaves like both a wave and a particle. Even single particles of light create these patterns, which is pretty mind-blowing when you think about it. Now let's explore an amazing idea that connects rainbows to the fabric of the universe itself: string theory. This theory suggests our universe has more dimensions than we can see, all curled up in tiny spaces around us. Some scientists wonder if the unique way rainbows split and bend light might be showing us hints of these hidden dimensions. When light travels through a raindrop, it's not just separating into colors, it might be interacting with these extra dimensions in ways we're just beginning to understand. Think of a rainbow as nature's own particle accelerator, with each raindrop acting like a tiny lens that reveals how light dances through space and time. While we can't prove these extra dimensions exist yet, studying how light behaves in rainbows could help us unlock some of the universe's deepest mysteries. Here's where rainbow physics gets really wild. According to the many worlds interpretation of quantum mechanics, each path light takes through a raindrop might exist in a different parallel universe. When light enters a raindrop, quantum physics says it explores all possible paths at once. Some scientists suggest these paths could be windows into parallel realities. Every time you see a rainbow, you're watching light take countless quantum journeys, each one possibly happening in its own universe. While this might sound like science fiction, it's based on real mathematics and quantum theory. The same equations that explain how rainbows form also hint at these multiple realities. Think about it. Every rainbow you see is unique to you, and maybe that's because you're catching glimpses of light from countless parallel worlds, all coming together in that perfect arc across the sky. Let's explore one of the weirdest parts of quantum physics: entanglement, and how it shows up in rainbows. When two particles become entangled, they act like they're connected by an invisible thread, no matter how far apart they are. In rainbows, photons, particles of light, can become entangled as they travel through raindrops. When this happens, measuring one photon instantly affects its partner, even if they're on opposite sides of the rainbow. Scientists have actually created entangled rainbow light in labs, using special crystals to split photons into entangled pairs. This discovery could help us build quantum computers and create unhackable communication systems. Think of it as nature's most colorful quantum dance party, where light particles pair up and mirror each other's moves perfectly across space. Let's explore one of the most puzzling ideas in quantum physics: how the act of looking at something can actually change it. When we observe a rainbow, we're not just passive viewers. The rainbow exists because our eyes and brain process the light in a specific way. Every person sees a slightly different rainbow because they're standing in a unique spot and their brain interprets the light signals differently. Some scientists suggest that consciousness itself plays a role in how quantum events unfold. This doesn't mean we're making rainbows appear with our minds, but rather that the act of observation is part of what makes a rainbow take its final form. It's like the old question: if a tree falls in the forest and no one's there to hear it, does it make a sound? With rainbows, we might ask, does a rainbow exist if no one's there to see it? Let's explore how rainbows create their perfect color symphony. Each color we see has its own special frequency. Think of it like musical notes, but with light instead of sound. Red light waves vibrate about 430 trillion times per second, while violet light buzzes at an amazing 750 trillion times per second. The other colors dance between these speeds, creating a perfect scale of light. When sunlight hits a raindrop, it's like an orchestra warming up. All these frequencies are mixed together. The water droplet acts like a natural prism, sorting each frequency into its proper place. This sorting is so precise that we always see the same color order, making rainbows nature's most reliable light show. It's amazing to think that something as simple as a raindrop can conduct this incredible quantum symphony. Here's a fascinating possibility. When you look at a rainbow, you might be seeing light from multiple universes at once. According to some quantum physicists, every time light travels through a raindrop, it creates a kind of split in reality. Each different path the light could take might represent a different universe, all happening at the same time. The rainbow you see is actually the combined effect of countless light paths, each one possibly existing in its own reality. While this sounds like science fiction, it's based on real quantum mechanics. Every rainbow is unique to the person seeing it. Your friend standing next to you sees a slightly different rainbow because they're at a different angle. Maybe we're all catching glimpses of different universes, each one showing its own version of that beautiful arc in the sky. Let's look at how scientists are using rainbow physics to push the boundaries of what we know about light and the universe. Modern labs are creating artificial rainbows using special crystals and lasers to study quantum effects we can't see in nature. These experiments could help us build better fiber optic networks, develop quantum computers that use light instead of electricity, and even create unbreakable codes for secure communication. Some researchers are using ultra-precise measurements of rainbow light to test fundamental theories about how space and time work. Others are developing rainbow-based sensors that could detect tiny changes in the environment or even help search for dark matter. The simple physics that creates rainbows might end up helping us solve some of science's biggest mysteries. Thanks for joining me on this colorful journey through quantum physics and rainbows. If you enjoyed unlocking these cosmic mysteries, hit that like button and subscribe for more mind-bending science. Share with friends who love exploring the universe's secrets.